guys, so in this video we're going to do electron configuration. So some things, and if it were me I would go ahead and mark these down on the periodic table, but these first two columns are the S block along with helium. The far right 6 columns, except helium, those are the P block. So this is S, P. The ones in between are D. The ones at the bottom are F. Some things I want you to go ahead and identify now. S holds 2 electrons. P holds 6 electrons. D holds 10 electrons. And F holds 14 electrons. So they go up by 4 every time. Okay, and if we look right here, this exponent, that's how many electrons we are into that block. And I'm going to kind of explain that more as we go through. Some of you may remember electron configuration and some of you may not, and that's okay. If you still do not get it after this, wait until week 2 opens. That first lab, the activity, electron configuration, it will help a lot. At that point, if you are still lost, please reach out and I will be happy to help you. Okay, so in electron configuration, we're going to have this code, and on the activity, it's called a manager's code, but it's just trying to make it more relatable. So the coefficient is the energy level, or the rho, generally is what it is. The letter is that block that we're in. They call it an orbital, but I don't love that because orbitals are going to be something different. And then again, the exponent is how many we are into that block. So S can only have 2 after it, up to 2. P can only have up to 6. Okay, we'll talk about the orbital diagram in a minute, which is what this is. So here helium is in row 1. It is in the S block, and it is the second electron in that S block. Okay, again, we'll talk about spin in a little bit. Yes, okay. The next thing I need you to know about this is the Aufbau principle. And that's that electrons fill from lowest energy level first. And the way to guarantee you do this is to go across periodic table. Like a book. Okay, so if we're reading it, we go hydrogen, helium, and then we're done with that row. And just like a book, if you were done with that row, you would go to the next row on the periodic table. And so we'd be looking at lithium, beryllium, boron, all the way to neon. Okay, so 1s, this is the first 2 elements. 2s is 3 and 4. 2p is 5 through 10, and we just keep going. Okay, this picture will make more sense once you do that activity. So again, Aufbau is that they fill the lowest energy level first. And that's the Aufbau principle. The next principle you need to know is the Pauli exclusion principle. It says that there's only 2 electrons per orbital. And these little boxes are the orbitals. You cannot have more than 2 because there's not enough space for more than 2. Okay, and then Hund's rule is the last rule you need to know. That says when they're filling them, place 1 electron before completing the pairs. I call this the bus seat rule. And when I was in high school and still currently in sports, Longview and Tyler are in our district for Mesquite. And so nobody wanted to sit by another person if you didn't have to. So a bus seat could hold 2, high schoolers. Ideally, 3 is really too many. But it was always better, especially when you left at 5 a.m., that you were in your own bus seat. You didn't have to share with anybody. And electrons are kind of the same way. They like their own space. They do not want to share with another electron because remember, they're the same charge and they would repel each other. They will if they have to, but they do not want to. Okay, so they're going to be individually seated until they have to pair up because there's no more space. Okay, so again, how they fill. Electrons will occupy the lowest energy level first, and then they will go to higher levels. And this goes through the order. Here, order. Okay, orbitals can hold no more than 2, and those are those little lines. So S has 1 orbital. So S is 1 orbital. P will be 3 orbitals because of each hold 2. D is 5 orbitals. And then F is 7 orbitals. And remember, they're going to fill individually before they pair up. So electrons first occupy orbitals singly with the same spin. Normally with Hund's rule, they go up first. And then they'll go down. All right, so it's writing these electron configurations. I wish it wouldn't have done that. Okay, so sulfur is the first one. I want to write its electron configuration first. So first thing is always easier to do is identify how many electrons based on the number of protons. Okay, so there are 16 electrons in sulfur because there are 16 protons. So then the next thing to do is to make sure you know what row we're on. And sulfur's on row 3, and it is in the P block. Okay, so it's not in the S block, it's not in those first 2, it's in the P block. And then once you've determined that, you go to the beginning of that P block, which is aluminum, and we count over 1, 2, 3, 4. So sulfur will end in 3p4. I do want you to make sure you're aware of, you have to account for all the electrons, not just that section we're in. So once you've determined our stopping point, we're going to go back to the beginning of the periodic table, and I'm going to write from the beginning. So I've got 1s, 2. And then I've got 2s, 2, because I write the end of each block. I've got 2p6, and I have 3s2. And then we get to our 3p, so we're good. The way to check if this is correct, or at least somewhat check, is you add up the exponents. So I've got 2, 4, 10, 12, 16. That does match my electrons. Once I have my electron configuration, I need to do my orbital diagram. So I'm going to draw lines. So this is 1s, 2s. I know in the PowerPoint and also in the activity that y'all are going to do, it shows them going up in energy level, and that's fine, but it really just takes up too much space. On Mastering Chemistry, it'll do that for you. Okay, once you've got your orbitals drawn out, which are these little lines, so this is an orbital, then we fill our electrons. So you have to fill them singly and then they pair. Because according to Aufbau, you've got to fill 1s before you can go to 2s. So 2p is really where we see Hund's rule. They go up, 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 and then they pair because of the bus seats. Okay, 3s fills because it's got 2. 3p, on the other hand, will look like this because it has 4. So this one has 2 unpaired electrons. The unpaired electrons must come from your orbital diagram. So this bottom one is the orbital diagram. This is called electron configuration. And we will talk about this more in chapter 3. Okay, this bottom one, it wants us to do argon. So argon is a noble gas. It is number 18, so we have 18 electrons. I'm going to write that up here. And it is, because it's a noble gas, it ends in 3p6. So I'm going to, again, start at the beginning. 1s2, 2s2, 2p6, 3s2, and then I left way too much room, so 3p6. Then we draw our orbital diagram. 1s, 2s. Notice I do have some space in between my different blocks. That is important, especially if we were in a class where I would have you write things out, because this is an online class. It's going to be a little different. But again, remember, you always go up, 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 and then you pair. So that one's its orbital diagram. It's got 0 unpaired electrons. Okay, now let's talk about core and valence electrons. So core are those inside electrons, and valence are the ones with the highest energy level or shell. Really, this is the highest coefficient. So here in silicon, I've got 4 valence electrons. Another way to tell valence electrons are those numbers at the top. Some of them are A's and some of them are B's. So all the A's are going to be your valence electrons. So in row 13 is boron's column. And it's column 13, but it's also row 3A, which gives us 3 valence electrons. Okay, and valence electrons are one of the most common ways that atoms behave. It's based on those electrons. So here, write the electron configuration for germanium, which is element number 32. And then identify valence and core. So that is in the P block. It is on row 4, and it is 2N. So we go 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Okay, the D block is different, and this is the first time we've seen the D block. That D block, that middle section, it drops down a row. So it's not row 4 according to its energy level. It really belongs to row 3, and you can see that when it was talking about Aufbau back in the PowerPoint. Okay, so this one's a little special. Once we have our electron configuration, then you look for the highest coefficients. These are our valence electrons, which is 4. I'm going to write VE. Okay, and then these are our core electrons, because they're not on that outside energy level. So you got to make sure you're paying attention to the outside energy level. Okay, one more. Let's do phosphorus. Phosphorus is element number 15. I'm going to start at the beginning. 1s2, 2s2, 2p6, 3s2, and 3p3. That is phosphorus. 3s and 3p, these are going to be valence. And all the rest are core. Okay, again, if you need help with electron configuration, please reach out. I will be happy to get on office hours with you, and we can hash that out some, okay? So, again, notice this block, this D block, even though it's on row 4, that's where it starts, this is 3D and 4D. It drops down a column. And actually, F also drops down a column. So F starts on row 6, but this is 4F and 5F. Okay, so make sure you have the blocks marked down on your periodic table. If you're using a printed one that you printed, you can use whatever you want. You could even print out this one. That's absolutely fine. All right, refer to our periodic table. Let's write it for selenium. Just the electron configuration. So we're starting at the beginning. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. It ends in 4p and it is 4p4. So if they were to ask us how many valence electrons this one had, it would be 6 because we've got 2 4s electrons and 4 4p electrons. Bismuth. Bismuth is element 83, which is very far down. So for bismuth, I'm going to teach you the noble gas configuration. I know we haven't talked about which ones are the noble gases yet. However, they are the very last column on the periodic table. So bismuth is, if we look, bismuth's kind of down here on the periodic table. It's on row 6. Okay, you go up a column and to the end, and that is xenon for this specific one. That's how you choose the noble gas. And by putting that noble gas in brackets, not parentheses, but brackets, I am saying I've got everything until xenon in its electron configuration. So then we do 6s2, 4f14, 5d10, 6p3. And if it were one that were this high, I would absolutely tell you to do noble gas configuration. Okay, I don't plan on asking you one of these. If I did, I would ask you what element this was, and you would just come to the end of it and find where that one belongs. All right, that's all for today. We'll see y'all next time.